Assalamu alaikum. My name is Muneeb Shah, and the topic me and my group partners chose today is Wi-Fi 6. But before we talk about Wi-Fi 6, we have to talk about Wi-Fi because Wi-Fi is the foundation of Wi-Fi 6. So let's get on with it. What is Wi-Fi and how does it work? Wi-Fi is actually the short form of wireless fidelity, and it is a wireless networking technology that allows devices to interface with the internet so that we get its services. And speaking on a technical note, 802.11, which is IEEE 802.11, has standard defined for the protocols which enable us to get communication with the Wi-Fi. Now to answer the question of how does it work? The way it works is pretty simple. It uses radio frequencies to send signals between the devices, and a setup of wireless network is starting with a wireless access point and a wireless router. And you must be thinking, what is a wireless router now? A wireless router allows you to use wireless signals or the Ethernet cables to connect to your computer and mobile and the devices to one another. Now coming to what is Wi-Fi 6? All the Wi-Fi up till now have their own distinct names, and Wi-Fi 6 has the name of 802.11ax. The basic task is to connect us to the internet, and but the main additional upside we get is that we get to do it with more efficiency and less latency. Now we're going to talk about need of Wi-Fi 6. As we live in a world which constantly looks for better and enhanced things, let alone technology only and everything. So the demand has actually increased. And due to this, the network performance is a necessity for companies to keep their employees and to please their customers. So another reason also to accommodate the growing number of mobile phones and IoT technologies, there is always room for improvement. And in our case, the improvement is Wi-Fi 6. That is our solution. So here are some key features of IEEE 802.11ax, which is Wi-Fi 6, and I'm only going to talk about long OFDM symbol, and my group partner Muzna will carry on the presentation from there. Long OFDM symbols. It is a feature that actually increases the duration of an OFDM symbol which was used to be transferred at the rate of 3.2 microseconds in Wi-Fi 5, and it transfers now at the speed of 12.8 microseconds on Wi-Fi 6. And it also supports a longer cyclic prefix for each symbol. A cyclic prefix adds a portion of the end of the OFDM symbol to the front of the payload. This is basically to provide robustness to our structure. The rest of the features will be discussed by Muzna.
Assalamualaikum. My name is Muzna and I'm going to further evaluate some of the key features of Wi-Fi 6. Another important feature that has been introduced in Wi-Fi 6 is orthogonal frequency division multiple access, also known as OFDMA. OFDMA basically allows multiple users with varying bandwidth to be served simultaneously. If we look at today's Wi-Fi as a delivery van, which delivers only one package on every trip, in comparison to that, OFDMA is like a delivery truck which carries packages from different senders on a single trip, which clearly is more efficient than the first one. OFDMA divides up the spectrum and allocates it to multiple different users if necessary. Instead of the traditional unmanaged approach where users used to compete with each other to send data, Wi-Fi 6 schedules them so they do not clash with each other. Coming to the technical terms explaining the working of OFDMA, OFDMA takes an RF channel instead of using a single carrier frequency. It sets out a number of subcarriers, each modulated independently and simultaneously, forming OFDM symbols separated in time by different guard intervals. OFDMA basically allows multiple clients with varying bandwidth requirements to be connected to a single AP simultaneously. OFDMA is ideal for low bandwidth applications and results in better frequency reuse, reduced latency, and increased efficiency. Handling data packets in this way improves performance as large number of packets can be transmitted simultaneously. Another key feature of Wi-Fi 6 is MU-MIMO, where MU stands for multiple users and MIMO for multiple input, multiple output technology. This technology was first introduced in Wi-Fi 4, which allowed multiple simultaneous transmissions, but only to one device at a time. In Wi-Fi 6, the technology was further enhanced and enabled multiple users to access a wireless network at the same time without any interruption. Wi-Fi 6 took this technology one step further by enabling devices to respond to the wireless access point at the same point, a capability which was missing in Wi-Fi 6. Additionally, Wi-Fi 6 has also enhanced the feature by allowing up to 8 devices to transmit simultaneously using one dedicated channel per device. This allows for large packets such as streaming HD video to be handled more efficiently, while shorter packets from IoT devices and voice traffic would be better handled using OFDM. Another key feature which I'm going to discuss is TWT, also known as target wait time. Device contention and the battery life of clients is enhanced by this feature, which is called target wait time, which basically lets the device to remain inactive until it is its turn to transmit data using a scheduling scheme negotiated with the AP. Because the devices can go into an inactive mode, the battery life of smartphones, tablets, and IoT devices is an underlying benefit. Another important feature is 104 QAM. So in Wi-Fi 5, we had a feature known as 25 QAM. When a wireless device transmits a message, it must send out an analog signal. This analog signal has two parts known as amplitude and the quadrature. By controlling the quadrature and amplitude, we can effectively transmit digital data over an analog signal. So this scheme basically deals with that transmission. So the 1024 QEM system used in Wi-Fi 6 divides both the amplitude and quadrature into 32 predefined levels. This gives a total of 1024 possible transmission values and allows up to 10 bits per transmission. Together with other things, security has also enhanced in Wi-Fi 6. So basically, WPA3 is a new protocol that has been introduced in Wi-Fi 6, which is more secure than the previous networks. WPA3 is the next generation of Wi-Fi security, where WPA stands for Wi-Fi Protected Access and 3 is the latest iteration. WPA3 introduces SAE, which stands for Simultaneous Authentication of Equals. And SAE is much more secure protocol compared to the previous one, which was used in WPA2, the pre-shared key. There are many other features that have been introduced in WPA3 that's make it more robust and more secure protocol. So it's quite enhanced and quite efficient. Another important enhancement that has been made is in IoT handling. IoT handling is also enhanced with an operating mode for low power, low bandwidth devices like sensors, automation, and medical devices. This mode separates these devices from Wi-Fi 6 AP using a 20 megahertz only channel that works in either the 2.4 or 5 gigahertz band. Another feature is of dynamic fragmentation. So in dynamic fragmentation, all of the packets of data are of different size. So they can better use the network resources rather than previously where we had static fragmentation, where all the packets were of same size. Now, Hamna is going to explain you some other important features.
Many of the innovations introduced in Wi-Fi 6 have shown impressive results. It's becoming clear that this is a technology to grow with. Wi-Fi 6 Basic Service Set BSS coloring is now entering the market and has great promise. BSS coloring can enable better spatial reuse through its understanding of the spatial relationships happening every day in Wi-Fi. It is important because the number of Wi-Fi stations being used continue to increase and the space between them is decreasing. It is a success story of sorts, but still a challenge that needs to be solved. Another key feature of Wi-Fi 6 is Uplink Resource Scheduler. Instead of the traditional unmanaged approach, where users compete with one another to send data in uplink, 802.11ax schedules them so they don't clash with each other. The managed approach results in better resource utilization and impressive increase in efficiency. It is possible that some stations will not be assigned an RU by the AP that is associated with. Trigger-based band random access allow RUs to be assigned for random access on the AP. Any stations that are not specifically assigned the RU will use the random access RUs. With change in time in system are replaced by more robust version. Different variations of Wi-Fi technology are compared in table. Wi-Fi 6 has a faster speed of 1200 MBs, operatable at multiple bandwidth channel as compared to Wi-Fi 5 and previous versions. Wi-Fi 6 has an upper hand on Wi-Fi 5 in many ways. First, talking about theoretical throughput, as Intel put it, Wi-Fi 6 is capable of maximum throughput of 9.6 GBs across multiple channels compared to 3.5 GBs of Wi-Fi 5. In theory, a Wi-Fi 6 capable router can hit speeds over 250% faster than current Wi-Fi 5 devices. Wi-Fi 6 has a better speed due to orthogonal frequency division, multiple access, OFDMA, MU-MIMO, beamforming, which enables high data rates at a given range to increase network capacity, and 102 for quadrature amplitude modulator, discussed before, which increases throughput for emerging bandwidth-intensive users by encoding more data in the same amount of spectrum. Wired and wireless connection come with its own pros and cons. When compared to Wi-Fi 6, the standard Ethernet cables have until now provide the fastest of internet connectivity. Ethernet and Wi-Fi 6 are still generally neck to neck on performance. Wi-Fi and 5G offer complementary functionalities. When the user experience is concerned, 5G and Wi-Fi 6 can both achieve gigabit speed and low latency. Some of the most exciting applications of 5G and Wi-Fi 6 will involve in the Internet of Things. Business can choose which wireless technology makes the most sense for these needs and still get the high capacity, fast speed, and low latency they need to ensure devices can share data quickly and more reliably. The new technology has its own perks. Wi-Fi 6 allows enterprises and service providers to support new and emerging applications on the same wireless LAN infrastructure while delivering a higher grade of service to older applications. This scenario sets the stage for new business models and increased Wi-Fi adoption. It provides more bandwidth, hence more data transfer. Not only this, bandwidth in scan subchannel is allowed to multiple access points for users. Hence, due to multiple path technology, throttling can be avoided, transferring more data at a time. Which can be seen here. Multipath environments help avoid throttling and congestion of data. And other, due to multipath technology, throttling is avoided. Another benefit of Wi-Fi 6 is an improvement in battery life performance. Connecting to Wi-Fi networks can quickly drain battery, especially when a device is moving in and out of range. Looking at the other side of picture, Wi-Fi 6 technologies are more expensive, requiring gigabit class broadband and provide a smaller range. So every technology has its own good side and a bad side, so it depends upon us how we use it and our purpose is served for different classes. So escalating to the end, there are numerous modifications being implanted in Wi-Fi 6 to fulfill the needs of new time and era. Thank you. Okay, so that's it from our side. I hope you enjoyed the video. Feel free to drop any queries or comments in the comment section below. Thank you again.